Let's solve this quadratic. Let's solve this quadratic equation here. So number 2, solve, ready? X squared plus 5x plus 6 equals 0. So what are the numbers that will satisfy this equation? Satisfy, we talked about yesterday, means you plug in the variable with a number, it results in a true statement. What numbers will satisfy? Well, instead of guessing, which you can go ahead and do if you want, you can use a method that I've already taught you. Let's factor the trinomial. X goes here, X goes here. 2 factors of 6 that add to be 5. How about a 3 and a 2? Sounds good to me. I just factored it. So I factor the trinomial, but we don't get all happy because we factored it. What do we do now, Ramos?
So now x plus 3 equals 0.
We set the first binomial equal to 0, and
X plus 2 equals 0.
the second binomial equal to 0. And lo and behold, that results in both of our solutions when we get x alone. Will this be on tomorrow's exam? Absolutely. You definitely know how to, you need to know how to solve a quadratic equation. Well, I'm going to give you a passing grade in math too. You got to know how to solve a quadratic. Simple as that. I don't care what you say. I don't care how much you whine. 0 minus 3. Okay, there's one solution. Right, Padilla? X is negative 2. There's your 2 solutions. Put 2 solutions on your notes. For the last day, that's awesome, Padilla. I've been saying that since the first day of school. No phones out when I lecture. What happened? Sure. What if a doubter were to walk into this room and say, you know what, we'll give you a phony. Negative 3 and negative 2 are not solutions. How would I prove them wrong? Very good. Wherever I see x, I'll replace with negative 3. Wherever I see x, I replace with negative 2. It'll satisfy. Well, let me show you that one of them. I'm not going to do both. I'll show you that negative 3 satisfies. Now, you can copy this down if you want. So I'm going to show that negative 3 satisfies. Okay, I'm going to show you that here. Here we go. Just in case there's any doubters in here. So, x squared plus 5x plus 6. X squared plus 5x plus 6 equals 0. This is the equation we solved. Let's show negative 3 satisfies. Wherever I see x, I'm replacing with negative 3. Now I'm going to follow order of operations. Exponent comes first, so negative 3 to the second power is positive 9. 5 times the negative 3 is a negative 15. Plus a 6 is 0. 9 plus negative 15 is negative 6. Negative 6 plus 6 is 0. It satisfies. Negative 2 would also work. All I did is check one of the solutions, but you can trust me that negative 2 satisfies also. Knock yourself out, check it on your own. All I did was replace x with negative 3, then simplify. Right? This is the equation we started off with right here. Yes? Question? Well, there's 2 x's, huh? So you have to replace both x's with negative 3. Wherever you see an x, you better replace it with negative 3. Right? Same x. This x is just raised to the second power. This one's raised to the first power. There's 2 solutions, huh? Negative 3 and negative 2. Right now, all I did is I verified that negative 3 works. So all this is just extra work. I'm just showing for any doubter that negative 3 does work. It satisfies. This would also be realized if I replace x with -2. I'm just too lazy right now to do that. But it would work. Yes.
X was a negative, you still solve it.
If x was negative, well, hold on, let me back up. We started off with the equation. Right. We finished it. Look at x at -3 and x at -2. We solved it. Valtiera, right now, all I'm doing is I'm showing that -3 is the solution. Because remember, a solution satisfies. Satisfies. I'm proving it, in other words. -2 would also work. But I'm not going to do that right now. Okay? Let's go on example 3. Pick it up a notch here. Another one here. Let's do this one, watch. Example 3 is right there. Copy that down. X squared plus 9x minus 12. The trinomial on the left, am I able to factor out a greatest common factor here? Is there a factor that 3, 9, and 12 share? 3, huh? So let's do that first. Let's factor out the GCF. 3. What's this? So what's going to be left over? 3 times what is 3x squared? Thank you. Actually, this is the same one for warm-up, huh? All right. Let's keep going. Watch this. 3 times a -4. Okay, cool. Now let's factor. So the 3 will stay here as a factor, but let's go ahead and factor the trinomial now with 2 binomials. So right now, just keep the 3 off to the side. It's really not going to matter in the end when I'm trying to isolate x. You'll see what I mean right now. So here, x and x. So a -4, but add up to be +3. What are 2 factors of -4 that add up to be +3? Actually, this is a little bit different than the warm-up, I think. Huh? Yeah, this is a little bit different. So right now, I need 2 factors of -4 that add up to be +3. That's the one. That's the one. I trust you guys see that. Okay. So at this point, everything's normal. Don't worry about that 3 factor. It doesn't matter anymore at this point. Because all I'm doing is trying to solve for x. So I'm going to get I'm going to take x minus 1, that first binomial, set it equal to 0. And the second binomial, set that equal to 0. And we're ready to rock and roll. Is x. Well, we took that factor, the binomial, and set it equal to 0. Now we're going to get x alone, because x is not alone right now. Remember, we want to know what x is. X is what? What do I do to both sides here? Add 1 to both sides. So look what we got. X then is 1. There's one solution. And -4, huh? Look at subtract 4. X is -4. There's our second solution. We solved it. Again, if I wanted to verify or prove to somebody that they are the solutions, I'll go back to the original equation, replace x with +1 or -4. It'll satisfy the equation. Right, it'll satisfy. That's called satisfy. It'll satisfy. I want us to use that word. It's actually on the sign of 14. You have to use that word. Last example. And I'm done with the second to the last lesson. There we go, last one. Last one. Example 4. Solve, ready? X squared plus 4x equals -3. All right. What's different about this one? Equals to number. Where the first 3 examples equaled what? 0. Very good. You guys are very perceptive. You guys are sharp. So what I want to do first then, if I have a situation like this, is I want to get 0 on one side. I want to move everything to one side and have 0 on one side. Doesn't matter what side the 0 is on, but let me get 0 on one side. I can do that in one step here. Add the 3 to both sides, and I'll have 0 on one side. Watch this. Look at. So I have 0 on the right. What's 4x plus 3? Thank you. One more time. Can't do that. Think of last week. Like terms. These are not like terms. So I have a trinomial. Look at. There's a trinomial on the left. Now we're back to square one. Talk to me, buddy. Talk to me. 4x and 3 are not like terms, so you can't. Remember the blocks? The square blocks with the long blocks? You can't add them. They're not like terms. So I got a balance. I added the same amount to both sides. So it's still balanced. It's still an equation that's balanced. All right, let's do it. Binomial, binomial. There's no greatest common factor, so I can't do that at this point. Let's just go right to the binomials now. X and x. Factors of 3 that add up to be 4.
3.
There it is. Now you with me. So our two solutions are x plus 3 equals 0 and x plus 1 equals 0. Let's subtract 3 from both sides. X is -3 and x is -1. We're in business. We're in business. That's the solution?
Yeah.
Should I? Why? Give me an argument. Give me an argument why I shouldn't.
Too early.
Too early.
You're already learning how to do it.
Well, you already know how to do it. You already know how to do it. We'll see. All right, I'm going to pass back test